NCERT class 10 chapter 4 carbon and its compounds. So guys, in this chapter mainly we are going to discuss about carbon and how that carbon will be reacting with other elements, why it will be reacting with other elements. All these concepts let us try to observe. You see, carbon is the element where we can find in maximum all substances. Whatever substance you take, definitely carbon is present in it. Though the direct availability of carbon is less in atmosphere as well as on Earth's crust, its availability is very less, but indirectly you can observe carbon in each and every substance. And how can we tell that carbon is present in that substance? In the sense, it is quite simple. You can take that substance and try to heat it. If you heat, you can observe the final product or the remains. If it is in black color, obviously we can tell that substance contains carbon. And over 3 million substances we can find carbon, and everywhere we can find it, so that it is very special element. And they'll ask you why that carbon is so special. We can tell 2 points. Number one, because of tetravalency, and number two, because of catenation. These are the 2 main points to tell carbon is so special element. Okay, we'll try to understand what is meant by tetravalency, what is meant by catenation further. First, let us see few basic things. You see guys, we have around 118 elements, which we are going to learn in 5th chapter. We have 118 elements. In that also we have metals, non-metals, and metalloids. You see, if you observe periodic table, this is just outline of the periodic table, where we can get 7 rows. In 5th chapter we are going to learn everything, and 18 groups. And here you can find hydrogen. Here it is helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And if you observe this one, carbon, that is the placement of carbon. If they ask you where carbon is placed in periodic table, carbon is placed in 2nd row. And if you observe the column, this is 18th, 17th, 16th, 15th, 14th. 2nd row and 14th group. 2nd row and 14th group is the place of carbon in periodic table. Now, carbon is represented with the letter capital C. Atomic number of carbon is 6. Mass number is 12. You see, atomic number is represented with the letter Z. In 9th class we have learned. Atomic number is 6 and its mass number. Mass number is represented with the letter capital A, which is 12. Okay, 9th class we have studied why that mass number will be 12. If you take any atom, definitely there will be electrons, protons, as well as neutrons. Right. Now if you observe this carbon, right, we have carbon, which is represented with the letter C, and its atomic number is 6. What is the meaning of that atomic number 6? It has 6 electrons, 6 protons, and 6 neutrons. Now, while coming to atomic number, always we prefer atomic number as proton count. See, this proton count only we are taking for atomic number. So that carbon's atomic number is 6. And while coming to mass number, in 9th we have studied, it is combination of proton count and neutron count. So protons are 6, neutrons are 6, 6 plus 6, which is equal to 12. And in this chapter, mostly we will be dealing regarding atomic number, not mass number. We are going only with atomic number, but not mass number. Okay, then you see, what is the meaning of the second row? Why it is that much important for us to learn that the carbon is placed in second row? You see, this second row, this 2 is representing number of orbits. Number of orbits. So carbon is placed in second row. So carbon has 2 orbits. It is simple. Okay. Carbon is placed in 14th group. Then what this 14 is representing? You see, always row number will represent number of orbits in the atom. Always this group represents number of valency electrons. Valency electrons. Now you see, carbon is placed in second row, I said. Second row in the sense that row always it will be representing orbit number. Means carbon has 2 orbits. We'll check it whether it is correct or not. And carbon is placed in 14th group. Always group represents valency electrons. So you see 14th group, for example, if you see this periodic table, this 18th group. Of course, in 5th chapter we will learn definitely. 18th group is known as stability element group. Stability element group or stability group, or we can call it as 0 group. These all elements are known as 0 group elements. Why? Because its valency is 0. Valency is 0. Now you see 14, how many places it is far? 1, 2, 3, 4. So 4 places far from 18th group. So definitely we can tell carbon has 4 valency. At the same time, we can tell carbon has 4 valency electrons. Guys, valency and valency electrons are different, not same. Don't get confused. Valency is nothing but it is combining capacity. Combining capacity of an element means something X element will be there. It needs to get stable. To get stable, how many electrons it needed? So to tell that count, we will use the word valency. So combining capacity, it needs how many electrons to combine with how many elements it will combine to get stable. So that combining capacity of an element is known as valency. And while coming to valence electrons nothing but number of electrons present in outermost orbit. Number of electrons present in outermost orbit. That is known as valency electrons. That is the difference between valency count and valency electrons. Don't get confused. Now, you see carbon. If you write electronic configuration of carbon, so see its atomic number is 6. You can write valence electronic configuration like 1s2, 2s2, 2p2. Or you can write this one as, you see what this one is representing. One is representing orbit number. What this S and P representing? It is orbital. What is this 2 representing? Electron count. So don't get confused. This one, this 2, it is representing orbit. S, P, it is representing orbital. This 2 number on powers representing number of electrons. Now you see, you can write this one as 2, 4. Your teachers might have told you. Why? It is written as 2, 4 in the sense, you see, in first orbit, there are 2 electrons. This is one bunch. In first orbit, 2 electrons. So that we are representing 2 here. You see, this is 2, right? 2 is nothing but second orbit. This 2 is also second orbit. So in second orbit, how many electrons are there? In second orbit, 2 plus 2, 4. So in second orbit, we have 4 electrons. So that we are representing 4 here. Now if you see, if you add 2 plus 4, definitely it is equal to 6, which is atomic number of carbon. Atomic number of carbon. So few points. Carbon is represented with the letter C. Its atomic number Z is equal to 6. Its mass number A is equal to 12. And while coming to orbits, it has 2 orbits. And while coming to valency, it has 4 valency. Means it needs 4 electrons to get stable. And while coming to valency count, there are 4 valency electrons. So carbon has 4 valency and it has 4 valency electrons. And while coming to its electronic configuration, it is 2, 4. Means, what is the meaning of 2, 4? In first orbit, 2 electrons. In second orbit, 4 electrons. That is the concept. So we'll try to understand again the difference between valency and valency electrons. For example, let us not take carbon, let us take oxygen. Oxygen represented with the letter O and its atomic number is 8. Now, if you write electronic configuration, it will be like 1s2, 2s2, 2p4. Because if you add 4, 5, 6, 7, 8, that numbers which are represented on top, if you add, that should be equal to its atomic number. Okay, so we got 2, 2, not 2, 2, 4. It is 2, 6. Why it is 2, 6 in the sense, in first orbit, it has 2 electrons, so 2. This entire is second orbit, because 2s, 2p, both are second orbit. So in second orbit, we have 2 plus 4, that is 6. Okay, you see guys, to represent this valency, we should have some idea regarding stability elements. We should have some idea regarding stability elements. What are those stability elements in the sense, if you observe the periodic table, here I have mentioned helium, neon, right? Now this 18th group element, if you observe, you need to understand about 6 elements: helium, neon, argon, krypton, xenon, radon. Helium atomic number 2, neon atomic number 10, argon atomic number 18, krypton atomic number 36, xenon atomic number 54, and radon atomic number 86. So these elements are stability elements. Now you see guys, oxygen atomic number, I said it as 8. Now oxygen atomic number is 8, and if you observe nearest stability element, we have helium, neon, argon. Helium atomic number is 2, neon atomic number is 10, argon atomic number is 18. And while coming to oxygen, its atomic number is 8. Now what we have to do, we have to compare this number 8 with these 3 numbers. So which number is very near, in the sense we can tell for 8, 10 is near. Because 10 is stable and 8 is oxygen, which is unstable. Now we have to take difference between these 2 numbers. Bigger number is 10, small number is 8, 10 minus 8 is equal to 2. Now what is the meaning of this 2 means? Oxygen needs 2 electrons to get stable. To get stable means if someone donates, if some element donates 2 electrons to oxygen or shares 2 electrons with oxygen, automatically oxygen will become 10, because oxygen atomic number is 8. Someone is giving 2 electrons, so 8 plus 2, it becomes 10. 10 is nothing but neon electronic configuration only. Now, how many electrons oxygen needs? We can tell it as 2. Now, valency of oxygen is 2. That's what I said here. Valence is nothing but combining capacity of an element. Means if oxygen combines with some other element, how many electrons it can get? It can get only 2. That's it. 2 is sufficient to become 10. 8 to become 10, only 2 electrons enough now. So that valency count Valency count of oxygen is 2. Now they will ask what, how many valency electrons are there? What is meant by valency electrons? Number of electrons present in outermost orbit. Now while coming to electronic configuration of oxygen, I said 1s2, 2s2, 2p4. Now number of electrons present in outermost orbit. What is outermost orbit? Outermost orbit is nothing but last orbit. You see here we have number 1 means first orbit. Number 2, second orbit. We don't have 3 na. So definitely second orbit is the last orbit. Now this is outermost orbit. In outer, what is outermost orbit? Second orbit is outermost orbit. In second orbit, how many electrons are there? 2 plus 4. Total 6 electrons are there in outermost orbit. Now valency of oxygen is 2, valence electrons 6. So try to understand. Well, coming to oxygen, valency count is 2. How many number of valency electrons are there? That is 6. So 2 in the sense it needs 2 electrons to get stable. What is this 6 is representing? There are 6 electrons in outermost orbit. So that is the difference between valency and valency electron. Next, we are coming to carbon. Carbon's valency and valence electrons both are same, 4. Because you write electronic configuration 1s2, 2s2, 2p2. Now, if you want to count valency electrons, what is valence electron? Outermost orbit electron. 1 is first orbit, 2 is second orbit. We don't have 3. So second orbit is only the last orbit. Now, if you count 2 plus 2, 4. So valence electron count is 4. Now, what we can do here again? Carbon atomic number is 6. This 6 is near to which number? Guys, 2 you can take, 10 you can take. 6 minus 2, I mean big number minus small number. 6 minus 2 is 4. Or if you take neon, big number 10 minus small number is carbon 6. 10 minus 6 is also 4. Whatever you do, we'll get 4 only. So valency is 4. Valency, electrons also 4. So it differs from element to element. Then we have studied a few things about carbon. So carbons, whenever, from now, whatever you are reading, only thing you have to keep in your mind that 2 things you have to keep. Number 1, its atomic number. Carbon atomic number is 6. Number 2, its valency electrons or its valency is 4. And most of the cases, try to remember this only. So from now, what are the topics we are going to learn? So it will be revolving around the count 4. It will be revolving around 4 only. Okay, now let us try to draw atomic structure of carbon. Atomic structure. Guys, atomic structure is different. Electron dot structure is different. So I'll try to give the clarification. In atomic structure, we'll be representing nucleus, we'll be representing orbits, and we'll be representing electrons. But while coming to electron dot structure, we will use symbol and we will use valency electrons. That's it. That is the main difference between atomic structure and electron dot structure. Now, while coming to atomic, first of all, let us try to mention electronic configuration. While coming to electronic configuration of carbon electronic configuration, 1s2, 2s2, 2p2. This also can be represented as 2, 4. 2 in the sense 2 electrons in first orbit, 4 electrons in second orbit. Now, let us try to draw atomic structure. You see, guys, there will be nucleus. Nucleus has protons as well as neutrons. Now, how many orbits carbon has in the sense 2 orbits, because we have 1 and 2. Right. We'll represent first orbit with circle, second orbit with circle. Now, we need to represent number of electrons. You see, in first orbit, there are only 2 electrons. So, 1 electron will be here, second electron will be here. However you want, you can represent electron, guys. Electron can be represented by using dot or by using cross. Either, whatever you feel comfortable, you can use it in your board examination also. There is no wrong in it. Now, so I'll be using a cross. Okay, 2 electrons in first orbit, and while coming to second orbit, this entire second orbit. Or if you feel any confusing here you can take first orbit 2 electrons. In second orbit, there are 4 electrons. You can represent 1, 2, 3, 4. So here you see, we have represented nucleus, we have represented orbits, we have represented number of electrons also in atomic structure. And in nucleus also, we can represent protons and neutrons. Now, while coming to electron dot structure, what we have to use? First symbol. Now, what is the symbol of carbon? It is capital C. That's it, C. And valence electrons. Valence electrons means number of electrons present in outermost orbit. What is outermost orbit? Second orbit is outermost orbit. Now this one. This is outermost orbit, and these are the electrons which are present in outermost. How many electrons present in outermost orbit? Only 4. Don't take 6. Okay, because we have 2 electrons in first orbit, 4 electrons in second orbit. Second orbit is the outermost orbit. We should not include first orbit. You see, here we have first orbit. After first orbit, we have second orbit. So that don't include the second orbit. Now, how many valence electrons are there? 4. So represent like 1, 2, 3, 4. And from now, we are not going with atomic structure. We are going only with electron dot structure further. So no need to remember this atomic structure. Please remember electron dot structure. Now you see, guys, carbon is so specialized because of 2 reasons. Number 1, here I have mentioned. Number 1, it is tetravalency. Number 2, it is catenation. In next class, we will learn what is meant by tetravalency and catenation. Before that, I would like to tell only one thing so that I can wind up this class. Carbon can combine. Carbon can combine with other elements. Carbon can combine with other elements. Why? To become stable. That is the only reason. To become stable. Okay. How it will combine with other elements in the sense, it can combine by single bond. We'll discuss what is that single bond in next class. Double bond. I'll explain everything. Single bond, double bond, and triple bond. So in carbon, combination of carbon, you can observe single bond between carbons or single bond between carbon and some other element. You can observe double bond between carbon and other elements. You can find triple bond between carbon and other elements. So what is that single bond? If there is only single pair of electrons, single pair of electrons should combine. Double bond means 2 pairs of electrons. Triple bond means 3 pairs. What is that single pair? What is the double pair? What is the triple pair? 3 pairs. We'll learn everything in next class. No worries. So just I'm giving some hints. Okay. Carbon can combine with other elements to become stable. How it can combine means single bond, double bond, triple bond. Single bond is represented with a single line. Double bond is represented with 2 lines. Triple bond is represented with 3 lines. Means carbon. Okay, let us take only carbons. Carbon can have single bond. Carbon can have double bond. Carbon can have triple bond. Okay, what is that bond? How electrons will be pairing? How electrons will be accepting that one? That and all we'll discuss. Just for your information, I'm telling you so that you will have some idea that what we are going to discuss in next lecture. Now you see, guys, I said we have to remember only electron dot structure. Right, we have to remember only electron dot structure. Now you see, sir, is that necessary for us to draw like 1, 2, 3, 4 means? No. According to the other element situation, carbon can react with some other elements. Na? So what is that other element? What is the valency of other element? X element, we don't know. According to the valency of that element, we can draw. So that can be drawn like this, or it can be drawn like this also. 1, 2, 3, 4. Guys, however you draw, there should be 4 electrons. That's it. Or you can draw like this also. 1, 2, 3, 4. That is also correct. You can draw like this. 1, 2, 3, 4. That is also correct. You can draw like 1, 2, 3, 4. You can draw like that. Or you can draw like 1, 2, 3, 4. That is also correct. You can draw like 1, 2, 3, 4. That is also correct. You can draw like 1, 2, 3, 4. You see, guys, if there is only one electron, it can go with single bond. If there are 2 electrons, it can go with double bond. If there are 3 electrons, it can go with triple bond. That is the logic there. Okay, here you see, it can go with single bond, single bond, single bond. Here it can go with double bond. Here double bond, double bond. Here double bond, single bond. Here single bond, triple bond, double bond, double bond, triple bond, single bond, double bond, single bond, single bond. So how we'll get that bond? Everything we are going to discuss in next lecture. So in our next lecture, we are going to see what is meant by single bond, what is meant by double bond, what is meant by triple bond, with examples. With examples, single bond in hydrogen, double bond in oxygen, triple bond in nitrogen, we are going to see. And we are going to see structures of different molecules, like how to draw H2O structure, how to draw CO2 structure, how to draw ammonia NH3, how to draw CH4 methane, that and all we are going to see. Then we will see what is meant by tetravalency, what is meant by catenation in next lecture. In this lecture, we have seen only introduction for this. That's it in this lecture.